Alright, today's lesson is lesson number 57. We are identifying parts of quadratic graphs. So we're going to continue talking about things that we talked about last week, like domain and range, and the maximum, minimum, increasing, and decreasing. But we're specifically focusing on quadratic graphs. So these are going to be graphs when we have x squared going on in our equation. So it could be like y equals x squared, or there's some other letters. We're going to talk more specifically about that in later lessons, but today we're just going to look at the graphs and see some of the key characteristics. Okay, so these are some definitions just to review. Again, domain, range, max, min, increasing and decreasing. So take a second to review these, and they should be in your notes from last Monday. Okay, so reviewing those terms, here is one of the examples. So the domain, I see the arrows on both sides here. So my domain is going to be from negative infinity to infinity. And the range, I'm looking at what y values are included now. So I see I start here when y equals 1, and I'm moving up from there. So my range is going to be 1 to infinity. Okay, and again, since I'm going up forever, I'm not going to have a maximum. There's no highest point, so no max. And then for my minimum, I'm going to have y equals 1. Okay, now I'm looking, where's my function going uphill, right? Where am I increasing? So that's going to be the interval from 1 to infinity. And then I'm decreasing from negative infinity to 1. Okay, so this is 1 on my x. I'm increasing for these red values, and then where the purple values, I'm decreasing. Okay. Alright, so these are the new definitions. Okay, we have vertex, axis of symmetry, x-intercepts, and y-intercept. So the vertex is going to be the point. It's an ordered pair where the quadratic has a max or a min. So it's going to be the bottom of the U or the top of the U. Okay, that's where your vertex occurs. The axis of symmetry is the vertical line that passes through this vertex. So it's going to be right through the middle. It kind of cuts it in half. Then your x-intercepts are where the graph crosses the x-axis, and the y-intercept is where it meets the y-axis. Okay, so here is our first example going through. We have the vocabulary that we've already done, and then our new vocabulary topics for this lesson. Okay, so for the domain, I have, again, the arrows go on and on, so I have negative infinity to infinity. Then the range, my lowest point is at negative 4. I'm going up forever, so this goes negative 4 to infinity. I don't have a max because there's no highest point. Right? And then my minimum occurs when y equals negative 4. Okay, I'm increasing. If I look at the graph, I'm going uphill on this part of the graph, right? So I'm going uphill for these x values. Writing that as an interval, it looks like the interval from negative 3 to infinity. And then same thing with decreasing on the other side of the graph. I'm going downhill as I move to the right. So that is going to correspond to these x values in purple, which gives me the interval negative infinity up to negative 3. Okay, my vertex is going to be the minimum point of this graph, so that's negative 3, negative 4. And the axis of symmetry cuts through that vertex, right, in a vertical line, so I have x equals negative 3. Sorry, it should be negative 3. Okay. The x-intercepts are where the graph meets the x-axis, so if I erase some of this, I can see that the graph crosses the x-axis at negative 5 and negative 1. So writing those as ordered pairs, I have negative 5, 0 and negative 1, 0. Okay, then the y-intercept is where the graph crosses the y-axis, so that's going to happen at 0, 5. Okay, on this example, we're going to go through a similar process. So again, the domain here is just going to be negative infinity to infinity, and the range goes from negative infinity up to 4, and this should actually be a closed bracket here at 4, because we're including that point. Okay, then the max happens when y equals 4, and we don't have a min because it goes down forever. So now I'm looking at where it's increasing. I see it's going uphill here in red, so that corresponds to these x values, which means I'm increasing from negative infinity up to 1 for my x values. Then I'm decreasing after that, right? I'm going downhill, so I'm decreasing on these x values, which is the interval from 1 to infinity. Okay, my vertex is the top of this u, which happens at 1, 4. And the axis of symmetry then is x equals 1. The x-intercepts happen at -1 and 3. So I have -1, 0 and 3, 0 as my x-intercepts. The y-intercept is here, so 3, 0 is the y-intercept. Okay. All right, and the next one is very similar. I'm not going to go through that on here. Okay. The activity then that we did in class was to make this train of cards. So we went from the start point, and then you have a kind of clue, and you want to find the card with the matching thing. Okay. So that was the activity that we did in class. If you missed it, these were the answers. So if you want to look at these just for some more practice, you'll see so this was start, and then you were looking for a card that had this range. So this graph starts at 3 and goes up forever, so this is the graph that has that range. Then we want a graph with a minimum at y equals -4. This one has a minimum here, and if you look closely, that is -4, so that's the correct card. This graph then has a maximum at y equals 2. Okay, so it corresponds to this one. And the graph on the next page will then have a range of -infinity to -4. Okay, so, So this one has a range of -infinity, and it goes up until -4. Then this graph is increasing on, let's see, -3 to infinity. So from this point on, it's going uphill. Okay, then this has a vertex at -1, 2. And the final graph is decreasing on the interval from -3 to infinity. It's going downhill. Okay. Then this has an axis of symmetry at x equals 1. The x-intercepts here are 2 and 4. This graph has a y-intercept of 0, 2. And the final graph has a vertex at 2, 0. Okay, so that was the activity in class. Okay, and then just one last thing. This is going over one of your homework problems for today. Going back to the multiplication of polynomials that we did, where we made a rectangle. Right? This problem describes a rectangle that has a width of x plus 8 and a length of 2x minus 4. So we know that we could solve for the area by splitting this rectangle up and solving each piece, right? So I could do that. 2x squared minus 4x plus 16x minus 32, right? Adding those, I would get an area of this. So I could say this is like the area of my rectangle, right? If you look at the problem, it's describing the rectangle that has these, this is the width and length, and then it also says it has a perimeter of 38 units. So we could say P equals 38. Okay, and if you think about perimeter is really just you're adding up the side lengths, right? So this plus this plus this plus this, adding that together. So you would have 2x minus 4 plus x plus 8. Those are just two of the sides though, right? So you also want to add another 2x minus 4 and another x plus 8. Okay, and then The problem is telling you that adding all of those together will give you a total of 38 units, right? And we can combine like terms here. So 38 equals, I have 2x, I have 2x, x, 2x, and x. So that gives me a 6x, right? And then I have minus 4 plus 8 minus 4 plus 8. So I get plus 8 overall. So I could actually solve for x in this case. Okay, so subtracting 8, I get 30 equals 6x, and dividing by 6, I get x equals 5. So this is just kind of a different way to use the rectangle that we talked about when we were multiplying polynomials. So we can think about area and even perimeter in this case and solve for x. Now that we have an x value here, we could actually plug that into our area formula. So plugging in for x, the x squared, I would get 25. So 2 times 25 gives me 50. Then 12 times 5 gives me 60 and minus 32. Okay, so adding these, I would get an area of 78 units squared. All right, that's all for today's lesson. Thank you.